Alright, so now we're going to write a quadratic function in vertex form from context, and then we're actually going to graph it, or we're actually going to do it simultaneously, because a lot of times it helps to graph or at least think of the graph as we're trying to put it together. Frank catches a baseball about 1 foot from the ground in the outfield. If you can imagine a baseball player in the outfield, he catches his ball, he wants to throw to home plate. After 2 seconds, the ball reaches its maximum height of 9 feet. So we can think the ball, he throws it, it's going to hit the max height, so we know this is some sort of sad face. After 3 seconds, the ball is now 7 feet high. Write a quadratic function. Okay, so just imagine baseball player, he catches it, he throws the ball, and then here's our x-axis, our y-axis, and here's our time because it's on the x, and after 2 seconds, it reaches its max height. So we don't know what's happening necessarily on this side, but after 2 seconds, there's our max. That's our vertex, so that's really helpful. That's going to be after 2 seconds, it reaches 9 feet. After 3 seconds, it's at 7 feet, so that gives us a second point. So here at 3 seconds, it's going to be at 7 feet. So we can see it's starting to descend. So we don't really know where it was here. Depends on the height of the guy, but we know it's going down. And so let's write it. So the first thing is let's fill in our vertex y equals a times x minus h squared plus v. And so y is equal to a x minus our h is 2 squared plus and v is 9. Okay, so what could a be? Well, a is going to be the change immediately after the vertex, that change that immediately happens over one increment. So it went down 2. So since it went down 2, that's our a. It decreased by 2. That's it. Pretty simple, right? So just make sure that if you got the vertex and you got the next increment afterwards, we can kind of fill in and we know what our quadratic function is going to look like.